Hello Eng 1060. In this video, I will cover how to use the fprintf and the sprintf functions. We have previously learned how to use the display function. The display function is quite limited in that it can only print one variable at a time or one string at a time. What if we wanted to print multiple variables in one formatted line of text? For example, we wanted to print the following statement. A is 5, while B is 4, and C is 58.5. This would not be possible with the display function. Another example would be the maximum cost is $54 with a corresponding radius of 6.14. We can achieve this using the fprintf function. So the syntax for the fprintf is fprintf, and then in parentheses we have a string, which is our format, followed by variables. The first argument is a string containing placeholders for our variables. The subsequent arguments are variables for our placeholders. So here I have three variables, var1, var2, and var3. The list of variables appear in the order that they are written. So here I have an example M file where I've prompted the user for an opposite length and an adjacent length. And from that, I can calculate the hypotenuse length. I can then print the information with the following statement. The length of the hypotenuse is given by %f. %f here is my placeholder together with my specifier. This string here is my first argument. The following argument is my first variable. Running this file in MATLAB will produce the following output in the command window. So I first have my two input commands, which I put in as 3 and 4. Following this, I have my fprintf command, which states that the length of the hypotenuse is given by 5. This value here comes from the hypotenuse length variable. So what the fprintf function does is it places the variable into the placeholder of the string. So the conversion specifiers tell fprintf where and how to print the variable. The percentage sign will tell it where, and the letter preceding it will tell it how. In this table, we have multiple specifiers. We have f being fixed point notation, e being exponential notation, d being decimal notation, g being whichever is shorter from f or e, and s being the string of characters. In this last column, there are several examples that you should familiarize yourself with. The order of your variables is very important when using multiple variables in fprintf. So here I have an example where I've prompted the user for 3 different variables. My first is name. Note that I'm using the s argument since I expect a string as an input. The same for location. My third variable is age. I can then use fprintf to print my information. The statement is my name is %s, age %z from %s. So for this particular example, my name variable will go into the first placeholder. My age variable will go into the second placeholder. And last, my location variable will go into the last placeholder. In MATLAB, the command window will display the following. I've entered my name as Batman. My location is Gotham City. And my age is 40. fprintf will then print the following command. My name is Batman, aged 40, from Gotham City. If you were to place the variables in the incorrect order, for example having location as first variable, age as the second, and name as the third, then the statement that will be printed by fprintf is given by my name is Gotham City, aged 40, from Batman. So it is crucial that you have the correct order when using multiple variables within your fprintf statement. fprintf allows printing of special characters. This enables better formatting and display of results. So we have something called a new line, which is represented by -n. We have tabbed spacing, given by \t. We can also delete characters using the \b. We can create a single quote using double quotes. And we can create a percentage sign using double percentage. Using the previous example, I have fprintf. My name is %s, aged %d from %s with my 3 variables. Note that in the command window, at the end of Gotham City, I have the 2 arrow signs, which denotes that MATLAB will continue on the same line. To improve the formatting, I can put a \n right at the end of my string so that MATLAB will continue its commands on a new line. I will now go through a few more examples with these special characters. So here we have %f, \n, and pi is our variable. In the command window, it would look like this. We can have multiple new lines by putting \n a few times, and this will create blank spaces. We can use the backspace to delete characters. So in this fprintf statement, I'm using the double quotation mark to create one quotation mark, as you'll see in the command window. This is followed by a string specifier. And since I have 3 \/ commands, it will delete 3 of my characters in Batman, therefore producing I'm Bat. We can create the percentage symbol by using 2 percentage signs. As shown here, interest rate is 6%. We can create tabs using \t. Therefore, this will produce a larger space between your words. And finally, we can use 2 single quotes to create 1 single quote. So here we have 1 quote to start the string and 2 quotes to create the single quote, which is equivalent to this quote here. Variables can also be printed with a specified width and precision. The width corresponds to the number of spaces used for printing, while the precision refers to the number of decimal places. The syntax is percentage, the width number, dot, the precision number, followed by the specifier. You should try the following commands in MATLAB to see what the results are. Here we have a floating point specifier. Next we have a floating point specifier with 2 decimal places. Third, again we have the floating point specifier, 2 decimal places, but now we have a width of 20. And for the final example, we have the exponential with 2 decimal places and a width of 20. fprintf works with vectors and matrices and prints each element. For vector, printing starts with the first element to the last element. For two-dimensional matrices, printing starts with each element in the first column, then to the next column, and so forth. As an example, here I have a vector x. Using fprintf on the x variable will produce the following output. So x is 489634. Note that the fprintf statement will be called for each element within x. So first we have x is comprised of 4, 8, 9, and so forth. We can also do this with a matrix y, and you should try this in MATLAB. The sprintf function works the same as fprintf, except that the resulting output is a string. This is useful for things like plot titles. As an example, here I have my plotting variables x and y. I've found the maximum coordinate using the max function and its index. I've then plotted the graph and labeled it. The important thing to note here is that the sprintf function is used within the title function. The statement chords for maximum equals my 2 placeholders is shown in the title. Remember that my first variable will go into the first placeholder and my second variable will go into the second placeholder. As a summary, in this video I have gone through how to use the fprintf and sprintf functions to print statements containing multiple variables. There are different conversion specifiers, so use the one that is most appropriate for your output. You can also specify the width and precision of the outputs. As a final thought for this video, why can't you use the fprintf function in the plot title?